Hello, this is my project. We're starting off in the main file. All the main file does is create the agent and run it. The agent, meanwhile, gets input from the user to determine the difficulty and search that it should run. I have not finished A star 2 at this time. I ran out of time to complete it. The set difficulty and each of the searches are in the search file over here. Set difficulty just sets the starting state depending on the input by the user. The breadth first search here starts off by creating a node, making it pushing it into a queue, and then popping it off the queue. This here is the output. We can worry about that later. Then it finds the existing children of that node by checking each action that can be taken on it, left, right, up, and down. That was not the previous action taken, or the opposite of the previous action taken. For the breadth first search, each of these nodes is pushed onto the back of the queue once it's been found. Then the node that we've been looking at is added to the expanded queue, which is actually a series of 9 queues that I've set up to act as my own version of a hash table for this problem. Then when it continues popping off each node, checking it against the goal, and then continuing to find that node's children if necessary. Once it reaches the goal state, it will create a solution list, which it gets pushed on the front, and then it follows back the parent pointers and pushes each parent onto the solution from the front. Then it starts popping these off once everything's been added and printing out the game state and cost, total cost, and depth. And then once it's completely done with that, it will print out the total cost, final depth, max size, and time. Then it clears out the makeshift hash table and breaks out of the search, goes back to the agent, and starts over again. For my depth first search, the only difference between that and my breadth first search is that the depth first search pushes the nodes onto the front of the queue as opposed to the back of the queue, so that the most recently added nodes are the ones expanded first. For my uniform cost search, the enqueuing I've separated out into its own function. Should be down here. Yes, it basically enqueues the nodes in order of least total cost to most, so that the least costs are popped off first. Then for the best first enqueuing, I've got that down here as well. It takes into account the heuristic of number of nodes in the number of tiles in the incorrect positions. Right over here. So that the nodes with more tiles in place first are explored first. And then for A1, the function here explores nodes that with a low combined heuristic and cost before more so. I did not get to A2, but if it did, it would be here. It would use the sum of the Manhattan distances instead of the number of misplaced tiles. Thank you for listening.